static and dynamic force analysis, right? So basically what we are studying is the static and dynamic force analysis. Now everybody knows this word, what is static and what is dynamics. Okay, static is nothing but the rest. So forces acting in the rest condition, forces in rest, and dynamic is all about the motion. Okay, the forces acting in dynamic condition or the forces of acting under the motion. Okay, so we have to do the static and dynamic force analysis. So basically, we'll start with the proceedings. Okay, so let me give you some slight introduction exactly what we are going to learn and exactly some introduction. Okay, now what I was saying, everybody knows IC engine basically. Why I am talking about the IC engine? Because here we are going to consider the force analysis of or the forces acting on the IC engine components, or you can say, like IC engine components rotate, components are rotating and reciprocating, right? The components are reciprocating, rotating and reciprocating. Okay. So basically, you know that when the components are rotating and reciprocating, okay, when the components are rotating and reciprocating, what will happen? The inertia forces will be generated. Inertia forces, right? Everybody might have heard this word, inertia forces. Okay. Then the effect of this inertia forces comes under the dynamic analysis. And there are a lot of static forces acting on the components also, like weight of the components and all. Okay, so that comes under the static, and the inertia forces come under the dynamics. Okay, so today we will understand this all, right, one by one. Now, before I start with, I wanted to give you some small introduction. Like basically, we'll be studying design, subject design in the next semester. But before that, I will not go into the detail. But just let us say, if you want to design a machine mechanism, if you want to design a machine mechanism, right? So basically, what you have to do first, if you want to design a machine mechanism, any machine, any mechanism, let us take an example of a IC engine only. IC engine only, okay? So you want to design let us say, can anybody tell me which mechanism, which is the mechanism used in the IC engine? Basically, anybody? You have studied in the kinematics of machinery. Just name, anybody can repeat. Which mechanism we are.
Cylinder piston.
What is that mechanism called as? Cylinder, piston, and all. Crank, connecting rod. What is that mechanism called as? Kinematics of machinery. I know you have studied it.
Oscillating
Cylinder
four
engine.
bar four bar
Oscillating cylinder
mechanism.
engine.
One more. Anybody? What is the name
Oscillating
of
Four bar
that?
cylinder.
mechanism.
It is called as a slider crank mechanism. Have you heard this word, slider crank mechanism? Have you heard this word? Or have you studied somewhere this slider crank mechanism? Anybody?
Yes, sir.
Yeah. So we are using a slider cam mechanism in the IC engine. Let us say you want to design that mechanism. You want to design a machine mechanism. Okay. So basically, if you want to design a machine mechanism, okay, machine mechanism. Let us say you want to design a slider cam mechanism. Okay, slider cam mechanism. So what basically you have to do? First of all, you have to do the analysis, right? You have to do the analysis. You have to do the analysis means what? Okay, you have to find out magnitude. In analysis you have to find out the magnitude, right? Magnitude and directions. You have to find out the magnitude and directions of forces, right? Of transmitted forces transmitted from input to output, right? Input to output. Okay, so basically, this is the analysis, you can call it as a. Means I am trying to say that I want to design a machine mechanism, let us say slider crank mechanism in case of the IC engines. Okay. So first of all, you have to do some analysis, right? So in this analysis, you are finding the magnitude and direction because there are forces acting on the machine or the mechanism. So magnitude and direction of the forces. What are the magnitude? What are the direction of forces which are transmitted from input to output? Obviously, you will have some input, you will have some output motion, right? Then basically, now you might question me, or you should question like this, sir, why we are doing this analysis, or what is the use of this analysis? Okay, so whenever you are doing an analysis, okay, it helps in selecting a proper size. See, when you are designing a machine component means what? Again, there are some parts of that particular, let us say, slider crank mechanism. So what are the parts? Crank, connecting rod, okay, piston, cylinder, okay, right? So there are some parts. So then you have to select some material and select the proper sizes. You have to select the proper sizes of, what you can say, you have to select the proper sizes of machine components. Okay, machine components means what? Crank, connecting load in case of the IC engine, right? So you have to select the proper sizes. Okay, see, I am not going into this in the next semester, and in the last year you will study machine design 1, machine design 2, what is the procedure and how to design that, how to design the gearbox, how to design the investing, sorry, how to design this IC engine mechanism and all. Okay, but just I am giving you the overview. So select the proper size of the machine components. Okay, now this is a stepwise. Now let us say, as an engineer, you are doing all these things. Okay, so let us say if you do not select, okay, if you do not select this properly, okay, I have a question to you. If you do not select the proper sizes, if you do not select the proper sizes, what will happen? If you do not select the proper sizes, what will happen? If you do not select the proper sizes, means what? You are not knowing how to do the static and dynamic analysis. You do not undergo the static and dynamic analysis of that particular components. Means what? You fail to select the proper sizes of machine components. Okay, this is the first case. Case number one, you are not selecting the proper sizes of the component. You are not doing the analysis. Can anybody tell me what will happen in that case? काय होऊ शकतं if you do not select the proper sizes of the machine components? Yes, what can happen? It is very simple, na? The machine component will fail. Means what? Your design will fail. The components will fail. The machine component will fail. How they will fail? How they will fail? The stresses will be developed, na? The stresses will be developed, right? See, you are doing the analysis, you are selecting the proper sizes of the machine components. Means what? Why you are doing this? Means what? You have to withstand the stresses. You have to withstand the stresses develop, right? See, basically you try to understand whenever the forces are acting, okay, whenever the forces are acting, the stresses will be developed, and you have to withstand the stresses develop in the machines, in the machine components, okay. And if you are not doing the proper analysis, not proper analysis, I can say, okay, what will happen? These machine components will fail, okay. Maybe this is the one side of the coin. What is the another side of the coin? What is the another case? Okay, if you are, let us say, if you are overprotective and you selected a material and you design a machine component for more strength. Okay, means what? You design a components for more strength. Okay, if you design a component for the more strength, you selected a very high grade material. तुम्ही खूप हाय ग्रेड मटेरियल सिलेक्ट केलं आणि तुम्ही त्याचे जे काही सायझेस आहेत ते तुम्ही सायझेस जास्त घेतले. फॉर एक्झाम्पल, if the diameter of 10 mm is sufficient, you selected diameter 100 mm. Okay, means what? You have designed for a more strength. Now tell me, again it is okay. What will be the disadvantage of this? The disadvantage of not doing a proper analysis, failure of the component, fail of the component. Okay, be fast. But if you're not designing if you're designing a component for a more strength, what will happen? What will happen? Anybody? Can you imagine what will happen in this case? Be fast. If I'm talking with you, be fast to answer. At least answer or message. Are you understanding what I'm trying to explain? No? Anybody? Hello? Am I audible? Okay. So if you're not doing a proper analysis, the component will fail. If you're designing a component for a more strength, what will happen? The cost will increase, na? Cost will increase. Okay. And if the cost increases, your product or your component is not able to compete in market, because let us say you are designing an IC engine component. So there are a lot of companies which are designing IC engine components. Okay. So you have to compete into the market. So you have to always design a good product at a lower cost. Okay. So normally the cost and this all is called as a value function. We call it as a value function. Okay. In case of the industrial design, we call it as a value function, right? So this is what uh, I have to explain to you. I hope you have understand the introduction. So I will go forward now. Now, okay. So that was the introduction, just to understand why exactly you should have the knowledge of static analysis, dynamic analysis. What is the importance of force analysis? That I have explained. Okay. Now, let's move to the forward. So first of all, let us understand the inertia force. Okay. Now, why I am explaining the inertia force? Now, already you know what is the inertia force. Okay. So first of all, before I help you to understand the inertia force, so first of all, tell me what is rigid body. Okay. Anybody know what is rigid body? Can anybody define what is rigid body? Because to understand the inertia force, you should know first of all the concept of rigid body and concept of inertia. What is rigid body? Anybody?
which cannot
Sir,
A
the
deform.
rigid,
body that cannot.
yeah, a rigid body is one which does not undergo any appreciable deformation while transmitting the motion. Means what? Let us say you are transmitting a motion. Whenever you are transmitting a motion, na? Transmitting the motion means what? You are transmitting the motion from the input to output. You are transmitting the motion from, let us say, input to output, or from, let us say, one shaft to another shaft, or let us say from engine to the gearbox. Okay, so the transmitting a, when you are transmitting a motion to output, there should not be no deformation, no deformation, or basically the accurate word is no appreciable deformation. Okay, means what? The slight deformation is acceptable, no appreciable deformation. So this is called as rigid body. So a body is said to be a rigid body when there is no deformation or no appreciable deformation while transmitting a motion from input to output. Okay, so this is the definition what we already know. And next is inertia. Can anybody define what is inertia? What is inertia? Inertia is a property of body by virtue of which, how can you define inertia? It is a property of body by virtue of which it remains in a state or uniform in motion until a force is applied on it. Right? So flywheel, for example, flywheel, okay? Flywheel, okay, then clutch plate of an automobile, okay? So they all have some, even we humans, okay? I mean even humans have some inertia, right? So what we call, ओके, सो व्हॉट वी कॉल दिस इनर्शिया. आपण इनर्शियाला मराठीत काय म्हणतो? जडत्व असं म्हणतो ना, जडत्व. आपल्या प्रत्येकामध्ये एक इनर्शिया असतं. सो द इनर्शिया विल बी लेस ऑर मोर. सो डिपेंडिंग अपॉन द कंडिशन, डिपेंडिंग अपॉन द डिझाइन, ओके, you have to understand this concept inertia. So inertia is nothing but a property by virtue of which it remains in a state or a uniform until a force is applied on it, right? And next, inertia force. Now, what is inertia force? Okay. Now, basically, first of all, inertia force is nothing but an imaginary force. Okay. Inertia force is nothing but an imaginary force, right? Which is which acts on a rigid body, right? It is an imaginary force. We call it as a imaginary force. Means there is some force which we call it as the imaginary force which acts on a rigid body. Okay. Now this force which acts on a rigid body, okay, what it does, what is the function of this force? First of all, the imaginary force which acts on a rigid body, the function of this force is it tries to bring body in equilibrium position, right? Am I correct or not? Have you understand what is rigid body, what is inertia force? Okay. So you know how to calculate this inertia force. In the further slides, I will help you to understand it. Okay. But imaginary force which acts on a rigid body, which tries to bring the body in equilibrium position, that is called as the inertia force. Okay. Now this is what you already know and what you have understand. Now basically I am doing the force analysis, that is static and dynamic analysis. So first of all, I have to understand how these inertia forces are generated. Okay. So basically you try to understand that when the components of machine accelerate, when the component, for example, you take a component of a IC engine, okay, so when the engine starts, okay, there are two types of motion in the engine. One is the rotating motion and second one is a reciprocating motion, right? So crankshaft is a rotating component, crankshaft is a rotating component, and piston, okay, piston, connecting rod, okay, so these are nothing but a reciprocating component. So there are both rotating and reciprocating component. Now this both reciprocating and rotating component will have the mass, right? Will have the mass m. Okay. Now basically the inertia force arises due to the mass of this rotating and reciprocating component. Try to understand it. So inertia force is related to the mass. Okay, basically you know this formula, F is equal to m into ma. So force F is equal to m into, that is mass into acceleration. So this F is nothing but the accelerating force. What is this F? F is called as the accelerating force. This F is called as the accelerating force, and inertia force is exactly equal and opposite to this inertia force. So this accelerating, so you can say that inertia force is equal to minus accelerating force. You can call inertia force is equal to minus accelerating force, right? What is accelerating force? Mass into acceleration. So what is inertia force? Mass into acceleration, but it is exactly opposite to the accelerating force. And what is this accelerating force? Okay, so this accelerating force is basically nothing but generated when the components of machine accelerate. Okay, so when the components of machine accelerate, inertia forces are produced due to their masses. That is what the inertia forces are produced due to the mass of rotating and reciprocating components. There is a mass of crankshaft and piston. So now tell me it is clear to you. Okay. So the inertia force arises due to the mass of the rotating or reciprocating part of the machine. So you try to fit in this in your mind. Okay. So now this inertia force, as I said, that is exactly equal to the exciting forces. Okay. So we can write this like this. So inertia force is denoted by Fi. So Fi is equal to minus m into a. Right. What is minus ma? Exciting force. Okay. And what is Fi? Inertia force. Okay, and inertia torque. Now see what is inertia force, what I have explained about the definition, how I have explained the definition. Inertia force is the imaginary force which is acted upon the rigid body and it tries to bring it into the equilibrium position. So this is, let us say it's a linear condition, but when you're talking about a torsional system, okay, when you're talking about a torsional system means what? Let us say there is a shaft, okay. So when this shaft is rotating, let us say this is a crankshaft, okay. So when this crankshaft is rotating, mt is nothing but a torsional torque, right? Mt is nothing but a torsional torque which is acting on the crankshaft or which is acting on the shaft. Okay, so this is called as a torsional system. So in torsional system, instead of inertia force, we will have a torque. Okay, so what is torque? Torque will be minus acceleration is equal to minus acceleration torque. So how we denote this? Ti. So Ti is nothing but inertia torque is equal to minus I into alpha. Okay, what is I? I is nothing but the mass movement of inertia of the body. Everybody knows what is mass movement of inertia. Mass movement of inertia of the body, and alpha is what? Angular acceleration. And here m is nothing but a mass and a is nothing but the acceleration, or you can call it as a linear acceleration. Okay. So this is how we define the inertia force. Now tell me, have you understand? Already you know this. Already you have studied this. I am just trying to revise because unless and until you understand this concept, you are not able to do the dynamic analysis of a slider kind mechanism. Now I am taking an example of a IC engine. Why? Because here, here basically we are understanding the dynamic analysis by taking a case study of slider kind mechanism. Case study of a slider kind mechanism. Now tell me, have you understand this concept? What is inertia force and what is inertia torque? Anybody? Have you understand this? Shall I move forward? Now B-Lambert's principle. Do you know what is B-Lambert's principle? B-Lambert's principle means what? Okay, it states that a body which is not in a static equilibrium by virtue of some acceleration, okay, which it poses, can be brought to a static equilibrium by introducing an inertia force. Okay, so this is, so basically this D-Lambert principle is related to the inertia force only, right? Means what? A body where which is body which is under the dynamic condition. So body which is under the dynamic condition means what? It will have some acceleration. Let us say x is the displacement, right? X we called it as a displacement. Okay, so rate of change of displacement with respect to time x double dot will be, let us say, velocity. X dot means what? I am taking a derivative of it. Okay, that is bx by dt. Okay, and x double dot is nothing but the acceleration, means what? D square x by dt square, double derivative. Okay, so this is displacement, this is velocity. So when, let us say, initially the body was in a equilibrium condition, that is a static equilibrium condition, and let us say now the body is under, now let us say you displace the body. from the mean position or from the equilibrium position. So velocity and acceleration will get induced. Okay, and if you want to bring back body to its original position or equilibrium position, it is done with the help of this inertia force. That inertia force, so this concept which is introduced by the scientists called as the D'Alembert's, so we call it as the D'Alembert's principle. So D'Alembert's principle states that summation of inertia forces plus external forces is equal to 0. Now we know that inertia force Fi is equal to minus m into a, right? So let us say there are number of inertia forces, number of bodies. Okay, so you can write like this: summation of Fi is equal to minus m into a. Okay, so what does the D'Alembert say? D'Alembert say that summation of Fi plus or summation of forces, or these forces are nothing but inertia forces, plus ma is equal to 0, or external forces. Okay, so this is nothing but, so summation of inertia forces plus external forces is equal to 0. This is the statement of the D'Alembert's principle. So this statement will be using in model number 3 to solve the problems. So here just I am explaining. Now tell me, have you understand this concept or not? Now I will help you to, now I will explain you what is, have you understand what is D'Alembert's principle, what is inertia force, what is rigid body and all? Anybody? Message me yes or no so I can move forward. Hello? Okay. Chalo, now static. Now guys, I am talking about the, see in this model we are just going to do the dynamic force analysis. But just you should understand what is static force analysis. So what is static force analysis? Now you have understand what is inertia forces. Okay. Now I think there is no question in your mind what is inertia forces. Okay. Now in case, let us say, let us take some a small example. If you take any example, and in that particular example, or in that particular example means what? In that particular machine mechanism, okay? In that particular, I will give you the example later on. So in that example, the magnitudes of inertia forces are negligible. Negligible means what? These inertia forces are very, very less. First of all, how are these inertia forces produced? These inertia forces are produced due to the masses of the reciprocating and rotating component. Means what? When the machine is under the dynamic condition. Means what? When the machine accelerates. So these inertia forces are equal and opposite to the accelerating forces, right? And these accelerating forces, which produces the inertia forces, if are very, very less, are negligible compared to the other static forces. Other static forces means what? Externally applied loads, or you can say the weights of that component. So whatever are the, whatever you know, na, static forces means what? The forces which do not change in the magnitude and direction. The forces which do not change its direction and magnitude are called as the static forces, and the forces which change its magnitude and direction are called as the dynamic forces, right? So if the static forces are very, very high in the magnitude as compared to this, then what we do? Then we neglect these inertia forces. Okay, and whenever you are neglecting these inertia forces while analyzing the mechanism, such analysis is called as the static force analysis. And this analysis is very easy as compared to the dynamic analysis. Why? Because this the force analysis is very, very easy, right? Because there is no any change in the direction of the force and the magnitude, right? So static force analysis is very, very easy. So now tell me, have you ever done the static force analysis in your last maybe 2 years? Any subject where you did a static force analysis? Yes,
Engineering mechanics.
mechanics. Yes. So in engineering mechanics, you have done the static force analysis. So what you do in the static force analysis, you find summation of Fi is equal to 0, summation of Fx is equal to 0, summation of m is equal to 0, right? So these are nothing but equilibrium equations. You have done this, okay? I will give you one practical example. So in the DMS, there is a subject called as a design of mechanical systems in your last year. See, in next semester you are going to study MD1, machine design 1, then machine design 2, 6th semester, 7th semester, and 8th semester you study DMS. So in DMS, you have a design of this lifting cranes. How to design this lifting crane. So there you will study. Okay. So that in that design, I will take an example. For example, in the, I'm not going into the design. I'm just taking example. So for example, in lifting cranes, the bucket load and the static weight loads are very quite high relative to any dynamic loads due to the accelerating masses. Okay. Whenever you are designing this lifting crane, for example, in design of lifting crane, the bucket load static weight loads are very high as compared to the dynamic loads due to extending masses. So in that case, you can go for the static force analysis. Okay. Next, now dynamic force analysis. Okay, now when these inertia forces are also considered along with the static forces, then the analysis of mechanism is called as a dynamic force analysis. Means what? If inertia forces, now this inertia forces Fi is equal to minus m into a, that is the exciting forces. If the system is a linear, if the system is a torsional, Ti is equal to minus I into alpha. If the system is torsional system, there is a torque. Okay, so in this case, if these inertia forces are high, okay, or relatively high, you cannot neglect this. Then you have to consider this. Then such an analysis is called as what? Such an analysis is called as a dynamic force analysis. Is it clear? So in this particular, you can say module, we are going to study the static as well as the dynamic force analysis. Okay. So let us understand more deeper insights into the dynamic force analysis. Okay. So basically, dynamic forces are associated with what? Accelerating masses. Exciting masses means what? The masses which are moving. For example, you take an example of a IC engine. So in IC engine, connecting rod, this piston, right? Then crankshaft, okay? They have some masses m1, let us say m2, m3, okay? So all are accelerating, means what? All are moving with respect to each other. They have a relative motion with them, okay? So means what? This CR, piston and crank are moving means what? Their masses are accelerating, right? So this you understand. So dynamic forces are associated with the exciting masses, and all machines have some accelerating parts. Dynamic forces are always present when the machine operates. This is a very important statement. All machines have some exciting parts. Dynamic forces are always present in that machine. Okay. So whenever the machine is operating under dynamic condition, dynamic forces are always present. But depending upon the magnitude, depending if the magnitude is very less, we will neglect that and we call it as a static force analysis. म्हणजे ह्याचा अर्थ स्टॅटिक फोर्स अनालिसिस करताना त्याच्यामध्ये डायनामिक फोर्सेस नाहीयेत असं नाहीये, ते आहेत पण ते खूप कमी आहेत म्हणून आपण ते निग्लेक्ट करतो आणि आपण त्याला स्टॅटिक फोर्स अनालिसिस म्हणतो. समजलं? Is it clear? But when they are not negligible, you have to consider that we call it a dynamic force analysis. Okay. Next. So in situation where dynamic forces are dominant, operating speeds are high, dynamic analysis has to be carried out. So where this dynamic forces means what? Inertia forces are dominant, are very high. Operating speeds are high means what? You are, let us say your IC is running at 5,000 RPM. Okay, the operating speed is very high. So the dynamic analysis has to be carried out. You cannot only do the static analysis. Is it clear? Is it clear or not? Okay, I will take an example. Now, for example, in case of a rotor which rotates with a high speed, even the slightest eccentricity of the center of mass from the axis of rotation produces very high dynamic forces. In case of a rotor which rotates with a high speed, even the slightest eccentricity of a center of mass from the axis of rotation produces. Means what? Let us say this is the axis of rotation. This is the axis of rotation, and let us say this is the CG. This is the CG of this mass. Okay. Now you can see that there is an eccentric distance E between the axis of rotation and the CG of mass. Okay. Now you have to always see some eccentricity will always remain, but you have to try to reduce this eccentricity. Okay. So if let us say that this particular mass, or you can say this particular rotor having mass m is rotating at very high speed, let us say 5,000 rpm. Okay. And if let us say this, you have some eccentricity, some centimeter eccentricity, that's the axis of rotation and mass, there is a distance between these two. Okay. Then in that case, okay, the high dynamic forces will be produced. Okay. And then you have to take care. And if you are not designing properly, if you are not taking care of these dynamic forces, can anybody tell me what may happen? What may happen in this case? In case of this rotor, anybody? In case of this rotor, if you are not considering doing the dynamic force analysis, and let us say the eccentricity is produced, that is the axis of rotation of a rotor, and the center of mass of this rotor has some eccentricity, what will happen? The vibrations will be. So this will be there is a model number 6. So in that model number 6, we are doing the balancing. So we are doing the balancing means what? We are balancing these dynamic forces as well as we are balancing these static forces. So Why you have to balance that? Otherwise, vibrations will be created, wear, noise, or even machine failure. So if you want to avoid this vibration, wear, noise, even machine, so you have to do the dynamic force analysis and you have to do the balancing. So this balancing we will study in the last model, model number 6. So these are interrelated to each other. I hope it is clear to you. Is it clear now? Anybody? So in this model, we study the inertia forces and their effects on the IC engine mechanism. Okay. So we have taken the case study as a IC engine mechanism. Now guys, tell me, have you understand about this model? Have you understand the basics? Message me yes or no. So I will move to the next part, dynamic analysis of this. Now I will move to the actual case study. Message me fast, have you understand this or not? चलो जल्दी जल्दी मैसेज करो. Have you understand introduction? See, I have given you the introduction because if I would directly started with this analysis, you might know all the concept which I have explained. Just I have tried to brush up. Okay. So is it clear? As a mechanical engineer, core mechanical engineer, you should know what are the inertia forces, what is the radial forces, what is the rigid body, what is dynamic force analysis, right? Okay, thank you so much. Now we will come to the case study, dynamic analysis of a Sider-Kang mechanism. Okay. Now this is a very huge derivation. This is a very huge derivation, and I will not go into the derivation. I will not go into the derivation. I will just explain you the concept. I will explain you the concept, and I will explain you the final formula. Okay. So basically, final formula means what? We are deriving angular acceleration. We are deriving the angular velocity. Okay. Of what? Of Slider-Kang mechanism. Okay. So in the notes, I'll be uploading the notes. In the notes, I have written the derivation. You can just go to the derivation and you will understand, no doubt. But the concept I will explain you, okay? Because as an engineer, if you understand the concept, you can go for the derivation. And in the exam, they will not ask you the derivation, okay? So I will directly go to the concept. Now let us say this is the Slider-Kang mechanism, okay? Now anybody have ever seen or ever known this Slider-Kang mechanism, okay? Now, in this, can anybody tell me what exactly the structure of this dynamic Slider-Kang mechanism is? Okay, so basically, what is this? Basically, can you see this is the point P, right? This is the point P. Forget about this point. So this is the point P, right? This is the point P, right? So what is this point P and this is point C? Okay, so this PC is nothing but what? Try to understand. This PC is nothing but what? A connecting rod here. This PC is nothing but a connecting rod. And this OC is nothing but what? This OC is nothing but the crank. Okay, so basically, Slider-Kang mechanism is nothing but the motion of a crank and connecting rod of a connecting rod of a reciprocating engine, right? This IC engine is a reciprocating engine, as well as it also has a rotating elements, that is a crankshaft. Crank and a connecting rod are nothing but the reciprocating. So this Slider-Kang mechanism, okay. So basically now, let us say that this OC is a crank, okay. Now this crank is rotating along this circle, right? This crank is rotating along this circle means what? This, let us say this C point will come to C dash, then from C dash it will come to the C dash. So what will be the radius of this circle? OC is nothing but the radius of the circle, na? So this crank, what is this OC? OC is called as the crank, and this OC, this crank is rotating about this circle. And when this crank is rotating about this circle, what will happen to this PC? This PC will reciprocate. Okay. So reciprocate means what? For example, let us say that when this point C will come to this C dash, when the point C will come to the C dash, where will this point P go? Where will this point P go? Let us say this C is rotating, and let us say theta is the, you can say the angle, okay, or you can call it as a crank angle. What is this theta? Theta is nothing but a crank angle. Means what? The angle by which this crank is turning about this circle OC. Okay, means it is having a circular motion, you can say. Okay, and at what speed or what velocity is running? It is running at a velocity omega radian per seconds, right? I am trying to explain the Slider-Kang mechanism. So when this OC will come to the C dash, it is called as the inner dead center. And when this OC comes to this ODC, it is called as the outer dead center. Okay. So when this OC comes to C dash point, okay, where will be this P dash point go? This P point will go to the P dash. Okay, and the distance between the P and P dash is nothing but the x. Okay, so what is this x? X is nothing but the displacement of a reciprocating piston P. X is nothing but the distance of a reciprocating piston P. Means what? This P is nothing but you can say the piston point, right? So here you know na how is the construction? The piston is connected. See, the piston is connected to the piston is mounted inside this engine cylinder. This is connected to the connecting rod. Then comes the crank, and then comes the crankshaft. Okay. So this piston will what reciprocate along with this crankshaft. Okay, and then this crank will rotate from inner dead center to ODC, ODC to IDC along with this crankshaft. Okay, now when this slider crank mechanism is operating inside the engine, there are a lot of forces acting on this particular mechanism. You have to do the analysis of these forces. Means what? You have to find out the expression or formula for these forces acting on the piston, connecting rod, crankshaft, right? So I am interested to find out what are the forces acting on the piston, what are the forces acting on the crankshaft, what are the forces acting on the crank, what are I am not interested in the not interested in the working principle that you will study in the IC engine. But here you understand the motion of this particular slider crank mechanism, and then we'll able to find out what are the forces acting. Is it clear? So that is all about. Okay. So consider the motion of a crank, and so let us go to the derivation part. That is the concept part. Consider the motion of a crank and a connecting rod of a reciprocating machine. Okay. Now let us say that OC be the crank, already explained, OC be the crank and PC be the connecting rod. Okay, OC means what? You can see this point O to C, right? And let the crank rotates with the angular velocity of omega radian per second. This crank OC is rotating it at what radius? Omega radian per second. And crank turns through an angle theta from IDC, right? Means what? Let us say initially the point was C dash. From C dash it went to C, and what angle it has turned? It has turned at an angle theta. Okay. So what is this theta? This theta is nothing but a crank angle. This theta is nothing but a crank angle, the angle by which the crank has turned, right? So basically, if you understand this, so when the crank is at a inner degree angle, so this theta will be equal to 0 degree. And when this crank will move to the C double dash, the theta will become 180 degree. So this crank, I hope you understand this. So this crank is moving from this point to this point. So it becomes a 180 degree. Okay. And at this point C, the angle theta will be equal to theta, whatever will be the value. Right? I hope you are understanding this construction. Then let x be the displacement of a reciprocating piston P. Let x means what? When this crank is rotating at an or the crank has turned at an angle theta, this connecting rod PC will reciprocate. So this is connected to the piston. This piston will also reciprocate means what? It will reciprocate. There will be the piston displacement inside the engine cylinder. The engine cylinder आतमध्ये तो डिस्प्लेस होणार आहे ना पिस्टन. मग त्याची जी डिस्प्लेसमेंट आहे ती आपण म्हणूया x एवढी आहे. Okay, means what? The distance between the P dash and P. Okay, so same I have mentioned here. X be the displacement of the reciprocating piston P from IDC after time t during which the crank has turned to angle theta. Okay, so this is I have considered. Is it clear? Is it clear too? Okay, and one more. Now let L is the length of the crank. L is the length of the connecting rod. Small r is the radius of the crank. Then what is theta? Theta is nothing but a crank angle. X is the displacement of the reciprocating piston. What is phi? Phi is nothing but the inclination of CR. What is CR? PC, connecting rod, to the line of the stroke PO. This PO is nothing but a stroke line. We call it as a stroke line. त्याला आपण काय म्हणतो? स्ट्रोक लाईन म्हणतो. तर या स्ट्रोक लाईन आणि कनेक्टिंग रॉड मधला जो अँगल असतो तो म्हणजे काय असतो तुमचा? पाय असतो. Is it clear? See, unless and until you understand all these concepts, you are not able to go for the derivation. Go for the derivation means what? See, basically आपल्याला काय करायचं लक्षात घ्या. I have to do the force analysis of slider or IC engine mechanism or slider crank mechanism. Means what? I have to find out the force acting at this point P, force acting on this PC, force acting on this OC, force acting on this crank, force acting on the crankshaft. Everything I have to find out, and do the analysis. Okay, and lastly, N is nothing but the L upon R. So in IC engine, this L upon R, that is a ratio of length of the connecting rod to the radius of crank, is very important from design point of view, and it is called as the obliquity ratio. It is called as the obliquity ratio. Okay. Now before I go to the final derivation point, tell me, have you understand this mechanism? या मेकॅनिझम मध्ये जर काही डाऊट असेल तर मला विचारा. हे मेकॅनिझम समजलं का? व्हॉट इज पीओ, व्हॉट इज पीसी, व्हॉट इज एसी, what is this IDC? IDC is nothing but inner dead center. ODC is nothing but outer dead center. Okay, means what? When the crank is at this position C dash, it is called the inner dead center. When the crank is at this position C double dash, it is called the ODC, outer dead center. Okay. Now basically there is a cycle which I will explain you later on. What exactly happens means what? There are two types of motion. One is the accelerating motion and second is the retarding motion. Okay, accelerating and retarding, or you can call it as a deceleration. Retarding means what? Deceleration. So during a half cycle, there will be the accelerating phase, and during a half cycle, there will be a retarding phase. This I will explain you later on in this diagram. Means what? When the crank is moving from IDC to ODC, the half cycle will be the accelerating, half cycle will be the retarding. ते मी तुम्हाला नंतर सांगतो व्यवस्थित. आता तुम्हाला ते कळणार नाही. पण आता तुम्हाला मला सांगा, तुम्हाला मेकॅनिझम कळलंय का? बी फास्ट. हॅव यू अंडरस्टँड द मेकॅनिझम? स्लायडर कॅन मेकॅनिझम समजलं का सगळ्यांना? की स्लायडर कॅन मेकॅनिझम काय असतं, त्याच्यामध्ये कुठले कुठले कंपोनंट्स आहेत? एनीबडी? ओके, चलो. नाव फर्स्ट ऑफ ऑल वी हॅव टू फाइंड आउट द पिस्टन, वेलोसिटी ऑफ पिस्टन. आता हे तुम्हाला कळलं असेल, पी इज द पिस्टन, पी इज द पिस्टन पॉइंट ना. सो पी म्हणजे तुमचा पिस्टन पॉइंट आहे. हा पिस्टन काय होतोय? रेसिप्रोकेट होतोय. कुठे रेसिप्रोकेट होतोय? इंजिन सिलेंडर मध्ये. एक असा सिलेंडर असतो इंजिनचा, हा सिलेंडर असतो, त्याच्या आतमध्ये हा पिस्टन असतो असा. ओके, त्याच्या आतमध्ये हा पिस्टन असतो. लक्षात घ्या, हा इंजिन सिलेंडर आहे ना तुमचा असा. हा इंजिन सिलेंडर आहे आणि ह्याच्या आतमध्ये हा पिस्टन आहे. ओके, या पिस्टनला असा कनेक्टिंग रॉड असतो आणि ह्या कनेक्टिंग रॉडला तुमचा क्रँक असतो आणि या क्रँकला तुमचा क्रँकशाफ्ट कनेक्टेड असतो. आणि हा जो तुमचा क्रँक म्हणजे थोडक्यात हा तुमचा पिस्टन, हा इंजिन सिलेंडर, हा कनेक्टिंग रॉड, त्याच्यानंतर इथे तुमचा क्रँक असेल आणि इथे तुमचा क्रँकशाफ्ट असेल आणि हा क्रँकशाफ्ट तुमच्या इंजिनच्या फ्लायव्हीलला कनेक्टेड असेल. अँड देन फ्लायव्हील इज कनेक्टेड टू द क्लच प्लेट. Okay, and this clutch plate is connected to the gearbox. Gearbox may be connected to the propeller shaft. Propeller shaft may be it is connected to the differential. Differential is connected to the wheels. Okay, so in the last year you will understand this powertrain. This is called the powertrain or transmission system of an automobile. IC engine, connecting rod, piston, crank, crankshaft, flywheel, clutch, gearboxes. Gearbox, again there is universal joints are also there. Propeller shaft is there, differential is there, differential shaft is there, bevel pinion. So it comes under the powertrain, right? You will understand later on. Okay, so let us now, I am not interested in that here. So let us understand the velocity of piston. So now there is a derivation basically. The derivation is very simple. You please go through the derivation in the notes. It is not needed here. I will directly write down the formula. So velocity of the piston. So you have to just remember this formula. How by doing an analysis, by doing a small analysis, 2-3 steps analysis. It is not so difficult. You are getting a velocity of piston of that slider kind mechanism. Okay, so that is denoted by Vp, which is nothing but omega r. You know what is omega, you know what is r. Sin theta upon sin 2 theta upon 2n. What is n? N is nothing but a obliquity ratio L upon r. R is nothing but a radius of crank. Omega is nothing but a angular velocity. What is omega? Omega is nothing but the angular velocity of that crank at which the crank is rotating, right? Okay, and theta is nothing but the crank angle. Okay, so you can calculate the velocity of a piston. So this velocity of piston is nothing but a Vp. You can call it as a linear velocity, or you can call it as a like this. This velocity is nothing but a Vpo. Means what? It is a, first of all, you understand there is a relative motion. Means what? This velocity of point P with respect to point O. Okay, so this Vpo is called as a Vp. Means what? Velocity of this point P with respect to the velocity of point O. Right now, so that is called as a Vpo, a linear velocity of a piston, because piston is moving like this. Okay, it is moving along the stroke line PO. Linear velocity of a piston means what? The piston is moving along this line PO. right? In both the directions, right? Either in this direction and in this direction when the crank is moving from C dash to C double dash. Right now means what? When this crank will move towards the C double dash, the piston will move towards this side. When this crank will come to the C dash, piston will move to. So piston is moving along the stroke line PO, along the stroke line PO, and it is having a relative linear velocity VPO is equal to VP. Is it clear? So this relative velocity of a piston, which is moving along the stroke line PO, when the crank is moving from IDC to ODC and ODC to IDC, vice versa, you can calculate like this. Okay? And acceleration of the piston. Now, when there is a displacement, what is the displacement? X is the displacement. So, what is this velocity? VP. Then, what is the acceleration? Because you know that when there is a X, there is a X dot, X double dot. Okay? So, what is the acceleration? Omega r into again how see basically you have to take the derivation of this linear velocity, right? Now after taking a derivative you are getting acceleration, so omega r into cos theta plus cos 2 theta upon n into omega, right? Is it clear? Have you understand this? Okay, now we have to modify this equation. Now tell me, when the crank is at IDC, first of all I have already जेव्हा क्रँक तुमचा इथे असेल, इनर डेड सेंटरला असेल, तुमचा थीटा किती असेल? एनीबॉडी? मगाशी सांगितलं थीटा किती असेल? हॅलो?
0
असेल. आणि क्रँक जेव्हा तुमचा ओडीसी असेल तेव्हा थीटा किती असेल?
180.
Okay, so you have understand. Now I have two formulas. So let us say if I want to modify this formula, means what? When theta is equal to 0 degree. म्हणजे काय? तुमचा क्रँक आयडीसी ला असणार आहे. मग जेव्हा तुमचा क्रँक आयडीसी ला असणार आहे तेव्हा पिस्टन मध्ये मुवमेंट होणार आहे, डिस्प्लेसमेंट होणार आहे. डिस्प्लेसमेंट झाली की वेलोसिटी होणार आहे, वेलोसिटी आली की एक्सेलरेशन येणार आहे. मग हा फॉर्म्युला काय आहे? सो व्हेन थीटा इज इक्वल टू 0, दिस फॉर्म्युला विल बिकम omega into omega square r. Okay, and what is cos theta? Cos 0 किती असतं रे?
1.
So 1 plus 1 upon n. So म्हणजे तुम्हाला फॉर्म्युला हा लक्षात ठेवायची गरज नाहीये. तुम्हाला फक्त कुठला फॉर्म्युला लक्षात ठेवायचा आहे? VP is equal to omega r sin theta plus sin 2 theta. त्याचा डेरिव्हेटिव्ह घ्या, तुम्हाला हा फॉर्म्युला मिळेल. And now when the piston is at the IDC, I am talking about a linear velocity, that is a linear displacement of a piston, that is a x about stroke line PO. I am not talking about the angular velocity and angular acceleration. त्यासाठी मला वेगळं डेरिव्हेशन करावं लागेल. Okay, is it clear? Now when let us say theta is equal to 180 degree, means what? Piston is at the ODC, sorry, crank is at the ODC. This formula becomes omega square r into, now what is cos 180? So minus 1, na? So minus 1 plus cos 2 theta means cos 360 1 upon n. Is it okay? So have you understand how this formula changes? So this is a dynamic condition. Crank is rotating from 0 to 180 degree. So there is a displacement of the piston upon the stroke line. हे तुम्हाला कळतं का बघा. ओके, म्हणजे पिस्टन हा जो x हे डिस्प्लेसमेंट आहे, this is above the stroke line PO, which is when this crank is rotating from C dash to C double dash and vice versa, and that is why because of this x dash VP is generated, that is VPO, velocity of a piston about the stroke line, and AP is generated, that is the acceleration. So these are called as the linear displacement, linear velocity and linear acceleration. Now angular velocity. Now angular velocity of what? Connecting rod. So connecting rod मध्ये काय असणार आहे? Angular velocity असेल, because what? Now piston is connected to the connecting rod. So connecting rod will also reciprocate. Okay, so considering the motion of the connecting rod and the crank, okay, considering the motion of a CR and crank, okay, you can find out omega PC, that is angular velocity of a connecting rod. So how can you find out this angular velocity of a connecting rod? By omega cos theta upon square root of n square minus sin square theta. Okay, and when there is an angular velocity omega PC, there is also the angular acceleration of connecting rod. So angular acceleration of connecting rod is given by alpha PC minus omega square sin theta n square minus 1 upon 3 by 2. Okay, so in this way, by doing some small derivation which I haven't taken, but you can look into the notes, not necessary, you can directly remember the formula, I can easily find out the linear velocity of a piston, acceleration of a piston, and omega PC and omega. See, first of all, tell me why I need this VP, why I need this AP, why I need this omega PC, and why I need this alpha PC. Because I have to find out the forces acting on each component. And if you want to find out the forces, it is a dynamic condition. So if you want to find out what are the forces acting on each component, what is that magnitude, what is the direction, you should know what is VP, what is AP, what is omega PC, and what is alpha C. Okay, so this I have found out from this small derivation, and I got this. Is it clear?